LAN Tamer stream. It's Monday night. We're going to do some labs on basic IP routing. I'm also kind of in the middle of an implementation, so I may have to do something here quick. Might take a moment. This is just some load balancer stuff I have to do. Dev team. But we're going to do the wallpaper of the day, of course. Back on the Twin Peaks theme. This is Sheriff Truman. Great character in the new Turn in Twin Peaks. This is the link of the day, which is Cisco Live. This was recommended to me when I was doing the EIGRP labs over the weekend. A Cisco Live session on EIGRP. I have not watched it yet, but I already know it's good. So if you want to add that to your list, feel free. It's really good. I'm sure that's going to be a good Cisco Live session on EIGRP details, which is great. Even the title looked pretty cool, which I did look at. So then we're going to get back to where we left off yesterday, which was policy routing. Telling them you're welcome. IM. It is. It seems like most work we do these days gets done via IM. I'm going to shut down my work PC now. But yeah, we're going to go back to the lab routing for, or basic IP routing section. And I just started yesterday on, let me pull it up here. That's our scratch pad. And I've got another, here's the requirements. So I got interrupted as I was doing this. I had to go do a pickup. But let's open our topology, which is here. Also need to kick off the simulation. And I was trying to remember what simulation I need to run. Basic IP addressing. Okay. So this is viral. This is the UWM. I'm using the dark. Basic IP addressing. Yeah. Quick launch. Okay, and while that runs, I'm going to look at these requirements again. Again, disclaimer, I'm using the INA workbook. So I'm not showing those materials on stream, but if you're not an INA user, I highly encourage you to obtain their products and services. They're excellent. That's what I'm using to help me prepare for the lab for the exams. I did not make up the topology nor the actual lab itself. That is all INE. I'm just kind of documenting for you my journey and my struggles in and out of these labs. So that disclaimer being said, this is our requirements for the first lab. It is, we have to do some default routes because we're not using, in this lab, you know, we already did last weekend all the dynamic routing protocols. So this is just default routes, some static routes, and then we're going to do some policy routing, which I have not done in a while. So I'm probably going to have to consult the documentation on this, but again, this is something that I didn't even know you could do really on a router until I thought everything had to be either static routing, manual routing, or dynamic routing protocols, but policy routing comes into play. That's what we're going to do on this one. So we're going to do, first of all, the requirement says, I look a little red here, don't I? Let's adjust that real quick so I don't blind you guys. There we go. Might be a little contrast. This is always a challenge. Depending on what shirt you put on, that changes how the chroma key setting here in OBS and that's a little more natural. The chroma key setting is always a challenge with this green screen that I'm using. So looking at these requirements, default routes. So let's go ahead and get our router set up here. I could do default routes. That's not an issue. We got router 1, router 3, router 5, router 4, and router 6. Pretty extensive here. This is why we like dynamic routing protocols, because it saves us a lot of time, right? One, 3, 4, 5, 6. Yeah. And essentially this, I think what we're going to be doing, 1, 3, 4, 5, 6. So we're going to be working with these segments here as part of the network. And making sure this is loading here. Let's take a look at the visualization. Oh, right, we found a way to shut down these nodes just here, right? Yeah, I don't need to start the switching nodes, so we're going to shut those down. You can close that as well. We know what our simulation looks like. All right. Router 4 and router 6. We want a default route to router 1's shared segment. Okay. Route 0.0.0 1.146.1. Oh, this is on router 5. This on router 4. And router 6 as well. We want that. And then a router 3, want that going to router 1 shared segment. It looks like router 1 is going to be the center of this. That's going to be 13.1. Then a default route to router 1's DMVPN on router 5. So everybody's getting default routes here. 0.1 is what that is. Now router 3 is going to have to router 5's L0 DMVPN. And then router 5, okay. Wait a second, I thought this says router 5. Oh, a static route, not a default route. A static route. Okay, router 3, default route to that on the wrong router. Then we want a static route to router 5's loopback 0, which is 150.1.5.5 via 150.1.0.5. That makes sense. So now router 5, we want a static route to router 3's loopback towards DMVPN. Okay, then we do policy routing. All right, so I'm just going to go ahead and look this up. Configuration guides. I think there's a section, protocol independent, policy-based routing. Got several PBR. Don't know if this recursive next hop is what we want. Basically, it's via route map, right? Set IP. I think this pretty much looks like what we want to do. We create an access list, a route map, set IP next hop. Yeah, that's what we're doing. So we don't need this recursive. That's not what we're doing here. So we can do a match, then a set next hop, right? And it's telling us here, we want to do policy routing. Anything coming from router 4 will go to router 3's on router 1. Traffic from router 4, get this details here. So that traffic from router 4 is routed through router 3 over the Ethernet link. Okay, so on router 1, traffic from router 4 is routed through router 3 over the Ethernet link. Traffic from router 6 is routed through router 5 over the DMVPN cloud. Okay. Trying to think of what a case would be, how we would even use trace route and router 4 for router 3 and router 5's loop back prefixes to verify your configuration. Okay, so I think what's going to happen is we're not going to have a route from router 4 to router 3's loopback when we're all done. So router 4, for example, he has a default route here, but router 1 will not have any routing configured. No static routing and no dynamic routing. So the policy routing is just installing routes in the routing. Well, it's installing paths in the forwarding table, because otherwise it has no way to get there, right? So what we want to do here on router 1 is configure access list 10 permit. All we need to know here is the source, right? So the source here will be 15.1.146.4 access list. I think they want to use names though. Yeah. So this is going to be, if it has to be named, it's going to be IP access list from R4 to extended access list, yeah. IP access list from R4 and IP access list from R6. And net IP, and we just need a source, right? 5.1.146.4. Oh, this is going to be wildcard mask. Can I do host here? I think so. Permit IP host. I always like being able to use host where I can. Okay, then we're going to do route map. Route me. Permit 10. Match IP address from R4. Set IP next hop. B15. Let's see. Router 4, we're going to go to router 3's Ethernet segment, which is 5.1.13.3. Then we want route map, route me 20, match IP address from R6, set IP next hop. Set IP next hop should go to router 5's DMVPN 0.5. Okay. So that's all we have to do. Let's see, let's do IP access list from R4 at IP host 5.1.1.6.4. IP access list from R6, IP access list extended. At IP host 151.146.6. If we have to put a destination, that I can't remember if we do, let's say any. Match IP address. I think that's all we have to do though. All right, so let's put this in. Router 6, going to router 1, router 4, going to router 1, router 5, go to router 1, back, router 3, router 3, going to router 1, router 5, loop back, going to 5, DMVPN. Okay. I guess we have to verify those too, but let's go ahead and see where this takes us. Terminal. What? Oh no, I was gonna say incomplete command. Yeah, I think I had to do any here. I thought I might have to do that. Don't we have to apply the route map though? Yeah, we have to apply the route map, the policy. There's an IP policy command. IP policy, route map, route me. Yeah. Thought there was something with 016. Okay. So show IP policy, show IP route map, show route map. Okay. Deal. We were close. Now let's put the static routes. 3, 5, 6. Then 4. Five, 6. Okay, static routes added. So let's test it out here. We want to verify. From router 4 to router 3's back. It even says that trace route. Uh, 150.1.4. No. 3. Looks like it reaches there. Trace route. R4 and R6 router 3's and 5's loopbacks. Okay, so now on router 6. To router 5. Did that. Router 6 to router 5's DMVPN. Did I do that right? It's not. 5.1.0.5. Pint. Yeah, I'd like to have a pint. It's from router 6. Show access list. We have no matches. Cannot reach router 6. Why is that? Interface down. 6.6. What did I try to ping? Or okay. Here I'm router 6. I can ping router 1. To router 5's DMVPN. Oh, I didn't apply a policy to that interface. Well, no, it's on the incoming interface. Show route map. From R6, set the next hop 155.1.0.5. Let me check router 5. Yep, that one is unreachable. I'm not too worried about that one right now. Router 6 to router 5's DMVPN. Router 5 should have a default route to router 1's DMVPN. Problem. Show IP route. Yeah. That looks like that works. Router 6 should have a default route. Does it not? Oh, did I not put that in? Okay, might be the issue. There we go. All right. Left off router 6. Sorry, router 6. Okay, router 3 should have a static route to router 5's loopback 0 DMVPN. Now, router 3, router static route, router 5's L0 DMVPN. Static route to router 5's. Can it even ping? Right. That may be just used to kind of throw us off because use trace route in router 4 and router 6. Yeah, that's all we have to verify. I think they're just throwing this in there just to distract us. All we have to do is meet the requirements, which we have. So let me check the lab. Cheppy. Yep. That is correct. Yeah, show IP policy. Did that already. And I did show route map. Okay. And they do this too. They say on router 6, ping 150.1.5.5. I try to ping it from source 0, right? Because the policy does not match. It only matches from the Ethernet interface. Good deal. All right, that was easy. I think one part I had to, just kind of thinking about it, is the format of my access list. I can do host, but I have to put a destination. And remembering to use this IP policy command. All right, so let's take all this out. And we'll move on to the next. What is the next one? Reliable policy routing. Good, I need practice on this. This is IPSLA stuff, I think. Probably gonna have me do the same things. That's okay, we'll do it over. I need the practice. Alrighty. Requirements. I think this is the last policy routing. Configure default routes on router 4. Okay. So let's go router 4. Oh, this requirements, right. Configure default routes on router 4. That's okay. Router 4 and router 6 pointing to router 1's IPv4 address. Right. Same thing. Configure default route on router 3. Pointing to router 1's IP address from the shared segment. Okay, and on router 5, pointing to the tunnel. Static routes on router 3 and 5. Static route on router 3. It's 3, 5, 6. Static route on router 3 for router 5's loop back. To the DMVPN cloud. And on router 5 for router 3's back. Configure router 1 and 5 to run CDP. Okay. CDP enable. This is router 3. So router 1. Configure an IPSLA instance on router 1 that pings router 3's connection to VLAN 13 every 5 seconds. Okay. Router 1. All right, here we go. IPSLA. Let's see how we do. ESLA 1. CMP echo. Frequency 5. ICMP echo 15.1.13.3. Then we want to exit IPSLA 1 schedule start time now. Exit. Track 1. SLA 1. Reachability, is that it? I think so. Okay, configure an IPSLA that pings every 5 seconds, right? Configure policy routing so that traffic from router 4 is routed. Okay, same thing as last time. IP access list extended from R4. Permit IP host 5.1.146.4 any from R6. Traffic from router 6 is routed through router 5. Yes. So we want to create route map, route me, permit 10, match IP address from R4, set IP next hop 155.1.13.3. Do 20 from R6, set IP next hop 5.1.0.5. Okay, they want us to verify this. Then I have to do interface JAS046 IP policy route map route me. Okay, let's just make sure that this works. Then we have some other requirements here. Virtually the same. Actually want to make a habit of putting exclamations at the end here, just for efficiency's sake. Speed, it's about speed too, right? Okay, so router 1. Nope. So when I would get a IP, okay, let's go this far. Got this far, that's good. Schedule. Got these backwards. IP. I was close, man. One of these days I'm gonna get this. All right, now let's try it. Go wrong. Oh, IP SLA1. Okay. Enter. No IP SLA1. Right. Always remember that. Shoot. Oh, IP SLA1. The configuration is very particular. All right. Okay, we don't need to exit the second time. Track 1. Okay. IP SLA1. Jeez. Track 1. P SLA1 reachability. All go through? Okay. Show IP SLA statistics. Turn OK. Show track. Okay, good deal. Wow, we gotta get that nomenclature down pat. I should just do end beginning of these. That way, regardless of whatever mode you're in, yeah. Hey, DeBizzle, how's it going, man? Do I think I've retained a lot? It's a very good question. I'll say that for some I have. For some things I have retained a lot. It's still not where it needs to be, so it's not to the point where I'm as fast as I would like to be. Some of it's like on the tip of my memory, and but I'm remembering where to go find it. So how many times am I going to have to do these labs before I feel comfortable? Probably quite a few. Like, uh, and I'm noting these too. I'm noting these in a list. Some of them I made it through pretty quick. But yeah, retention's always an issue, right? But I think in the end, I'm going to have to do these labs quite a few times before I feel confident. Thing is, though, once you get used to doing the same labs, it loses its effectiveness, right? So I'm going to be seeking, at some point, I'll be searching for a new workbook. Sure. Try to keep training the brain. I've got all this configured. So let's just verify reachability. That was the main thing. On router 4, trace route. Oh, this from router 4. Yeah, that's correct. And from router 6. Good deal. Yeah. All right, so this all worked. This is basically the last lab we did, but Now we have a requirement. I actually did my routing config requirements window. Modify it so that if router 1 loses reachability to router 3, traffic is rerouted to router 5 over the DNS cloud. Interesting. So how do we assign tracking to a policy? Do we do that in the route map? Let's see, right now the route map. Match. Set IP next hop. I can do multiple. And I know how to assign a tracked object to a static route. Modify R1's policy routing. Uh, hmm. Oh, here we go. Set IP next hop, verify availability. There we go. Nice. On a route map, set the next hop. Depending on the state of the tract. So does it go by, it goes in order, doesn't it? So what we need to do is modify this. Say verify availability. And track number. What is 10? Oh, that's an order? Let's see. Set IP next hop. I don't have that option here. Set IP next hop. You know what? Oh. Set IP next hop. Verify availability. 151.13.3. Sequence number to insert into next hop list. 10, track 1. Okay, nice. Forgot all about this, but I found it quick. So, so I think I did. Set IP next hop, verify availability. 10, track. Track 1. Now we need a couple of these though, don't we? Modify so that if router 1 loses, traffic is routed to router 5. So set IP next hop. Let's see here. Verify if next hop is reachable. So I'm hoping it's going to process it. Okay, on this one, we want to verify if it loses router 5 as a CDP neighbor. I think all we have to do is that. Verify availability, and it will use CDP. Believe that's how that works. Okay, didn't like route map, route me per 20. Match IP address from R6. Set IP next hop. Or no. And so it seems like guess we have to, can we do a tracking object? IP SLA 2. All right, let's check back here and see if track CDP. What is that under IP SLAs? Here we go. Seems like a very very niche case here. I'm not gonna spend a lot of time. That's one thing I've learned is that, especially in I&E workbook, others have told me, there are a lot of these sort of niche cases. Okay, here's a way you accomplish this. It's not obvious at all. Set IP next hop. Set IP next hop. Verify availability. Set IP default, next top. Very niche case. I mean, one complaint there's been about INE is that you spend a lot of time on very unusual Yeah, I had to look at the answer, but can you even deduce that from, for example, let's look at documentation. Now Cisco, they put this freaking video on their homepage. That is so annoying to me. The longer I do these labs, the more annoyed I get at things like that. Probably wouldn't bother me before, but now it really does. So let's go to the command reference. I want to do that. Labs, go back, go back. Or, I wanted to look at set IP next top. It doesn't even give this as an example. Okay, here we find it. With policy bait to verify next using Cisco Discovery Protocol. Okay, is CDP enabled? It is. All right. So let's do some validation here. On router 6, or no, let's go to router 4. Trace route 150.1.3.3. Trace route 150.1.5.5. Okay, yeah, so right now it's a longer path, but we're policy routing so that it will go here and then here. But if this interface goes down, it should take the shorter path, right? So let's test that out. Guess we have to wait for the tracking to take effect, right? There it goes, up to down. Should that be set IP default next top? Ah, yeah. Very limited options. I mean, this is such a niche case. Let's see, verify about 151.13.3. track 1, set IP default stop .5. I have to unapply it and then reapply it for it to work? Did I not put these routes? Oh, I haven't applied these other configurations. Okay. So IP SLA should be down, show route map. Oh, this shouldn't be in here. Let's do this. No route map, route me. Show IP policy. Doesn't give you much there, does it? There we go. Yeah, I do too. Trying to trip us up. Yeah, one of the comments was that the NARBIC workbook seems to devote more time to actually learning the basic and essential configurations that you need to know. The I&E workbook has less essentials. It just kind of has more spotty essentials, and then it has a more difficult, like outlier, unusual cases filled in the workbook. Yeah, I guess I'm learning that there are pros and cons to each of the different workbooks, right? Um, so, all right. So I think we're good here on this one. Let's bring that back up. Part of it too, man, is just I'm still weary. Like I have not recovered from all the labbing. I labbed 30 hours over Labor Day weekend. My brain is just, it's weary. No excuse, but uh, I'm not gonna lab a whole lot tonight. I'm gonna try to get some rest, more rest. It definitely like takes some of the, takes your edge out. Don't get the proper rest. Okay, this should change. Well, I have to wait for IPSLA to come back up on router 1, which it just did. There we go. Yeah. And let's test the other one out to tunnel 0. So theoretically on router 6, I trace route 150.1.3.3. Yeah, it's going to go through the tunnel, but if I shut down the tunnel interface, CDP should go offline. Immediately, and then going back to router 6, now it should route through router 3. CDP has a timer too, I've noticed. I forget what it is. I think it's like 30 seconds. Because if I look show CDP neighbor interface on 0, it still shows router 5. Actually, the whole time is longer than that. 130 seconds left. So we have to wait. This is not the most reliable. At least if we compare the two, I don't even know if there's a way to flush CDP. The only way I could think of is to turn it off and then turn it back on. Hold time, so we gotta wait for the hold time to expire. Clear CDP table, can we do that? Hey, look at that. Nice, so now, boom. Okay, I learned something there. Let's see what CDP looks like. I haven't really captured that in Marshark. At least I haven't looked at it. So let's go to unselect. How do I unselect the your way? So let's look on that on the tunnel interface, router 5. And is that protocol CDP? Is that a legit filter? Find out. Just be CDP, right? Sniff, CD, it is useful to add a regular artificial ping and trace routes. So is that an Ethernet type? Ethernet. Okay, let's try that. This is the filter used. So I don't know if the TCP dump and the BFD are the same. BPF, sorry, BPF. Ether Proto. All right, I'm going to do that just for fun. Okay, it didn't mind. So let's do shut and show. CDP takes a while to actually show. CDP neighbor will still receive. We have to wait for the tunnel to come up, right? Yeah. Tunnel's not up. Not yet. It'll be encapsulated though. It says it's up. 0.1. Now it's up. There it is, tunnel 0. All right, let's take a look at our capture. See if I got it right. Hey, that was right. It's kind of an obscure, huh? It's Ethernet. It's a certain Ethernet type. So, what was it? I got to document that. I'm not gonna. Did I close that window already? I'm bad about closing windows, guys. That's okay. That's why we have history turned on. Whoever this person is, I want to make a shout out to him. Carlos Perez. Thank you for that, my friend. I'm going to put this link in the notes. Um, darkoperator.com. I love the name of his site. That's cool. About me. Don't know what that is. No, that's email and that's Google Plus. Oh, GitHub. Okay. Interesting. All right. Appreciate the heads up, my friend. So now let's take a look at Cdp packets. This incorporates any of these ether types, doesn't it? BTP, DTP, PAGP, and UDLD. Wow. But here we see it's CDP, device ID. So look at all the information we get in an actual CDP packet. Oh, this is the port Ethernet type. Logical address, organization code, control field. Interesting. So the Ethernet destination 01000C. Is that a 01000C? Is that Cisco's? Is that like a global internet address? Wireshark OUI lookup. Zero 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 one zero C. Not really. Yeah, it's not really a MAC address, is it? Let's see. Frame encapsulation type Ethernet. Destination address. Source address. Okay. That destination. That must be like a special reserved Ethernet destination address. 0100C. Oh, is that an Ethernet multicast? Ah, isn't it? Okay. I've read about these. So isn't this interesting? CDP is shared with VTP, and it looks like it could also be DTP. So that's how that works. DTP, PAGP, UDLD. Unidirectional link detection, port aggregation protocol, dynamic trunking protocol, VLAN trunking protocol, Cisco discovery protocol. At least I know my acronyms. Interesting. Take a screenshot of that. Coloring rule string. Okay, let's collapse this. This. So here's all the information we get in a CDP message. Get the version TTL 180, right? Expire time, device ID, software version. You also get a website in your CDP message. Get an HTTP website you can look up. Platform length is 10, Cisco 17 or 1 address. Protocol length IP 4. Get an interface, sent through interface. Oh, and you get to prefixes. Yeah, that's right. Here's your ODR prefixes. And then your management address. This is all stuff we've seen, right? We do a show CDP. Do we see the one for tunnel 0? No, I didn't capture that long enough. I'm gonna take a packet capture of this because this will be a good like trivia question. I know I'm kind of a noob at this Wireshark stuff, guys. That's why I like every stop along the road. I'm like the kid who wants to stop at every mile marker and take a picture. Whee! Where's the stuff on for ODR addresses? Yeah. Now there's prefixes somewhere. There it is, IP prefixes. Yeah, we'll take a screen capture there. Okay. All right, guys. Well, that finishes that lab. I think we're gonna save GRE for tomorrow because I need rest. Thanks for tuning in. Appreciate everybody coming in the chat and watching the channel. Please like and subscribe if you enjoy these videos, and we'll see you back in the lab tomorrow night.